Buenos días. Hola, hola, probando. Mucho gusto. ¿Cómo están mis estimados aprendices? Espero que estén todo bien, todo azul. Let's spin video. Okay, guys, hope you're doing well. Today we're going to start with this next lesson. And this day we're going to talking about according from the determinants. Okay, we learn how to calculate the determinant for the matrix. But before to start the class, please turn on your camera. If I don't want to bother you, but this is a golden rule, right? Please turn on your cameras. Thank you, Joseph. Thank you, Sophia. Thank you, Victoria, Fernando, Ethan, Efraín, Oscar, Silvia, Manuel Santos. Please, everyone, turn on the camera before we start the class. Okay? Okay, thank you, people. Turn on the camera. Thank you, Sophia. Okay, thanks for letting me know, right? Now, all right. Thank you, Manuel, for turning on your camera. Thank you so much. Okay, then let me change the camera view. And let's begin, right? We have obviously we have obviously the new lesson talking about the determinants of the matrices. Okay, in this case, we were talking about according to how to calculate that. What is the determinant? A determinant can be defined like a matrix scalar. What I'm trying to say is, if you remember, you take a product between the number and a matrix, that will be the scalar rather than the matrix. But in this situation, we're going to have a matrix, and for that matrix, we can create a number. Or this is the opposite process. If it is worse. But let's going to start how to calculate the matrix 2 times 2. For example, given matrix A equals A. Okay. So then this matrix can be the determinant of A, D, E, T, determinant. To the cost and subtraction. Well, what does that mean? I'm going to multiply A times subtracting A times. This is going to be the formula for the calculated determinants. But before to continue, guys, let's confirm. Can you see perfectly well the things reading the whiteboard? Let's confirm. Yes or no?
Mister. Yes.
Okay, perfect. Can you hear my voice loud and clear?
There's a little echo, but I can understand.
Un poco suave, ¿se escucha?
Un poco, hay un mini eco, pero sí se le entiende.
Ok, perfecto. Ya. Okay. Permítame un segundo. Ahora sí. ¿Qué tal ahora?
Perfecto.
Okay, excelente. Better. All right. So once again, what is the purpose of the matrices? If you remember the first lesson when we learned to add and subtracting matrices, before to multiply the matrix, we applying the product between a scalar and a matrix. I mean, for one number multiplied by the matrix generates another matrix, okay? Now, this time, that determinant has been useful to obtain the opposite, okay? You're going to have a matrix and to obtain the determinant, you're going to obtain the scalar. I mean, the number. Could be a whole number, could be a fraction, could be positive number, or could be a negative number, all right? So, and we have a formula for the matrix A. giving 2 times 2, as a matter of speaking. A equals A, B, C, D. Then determinant A will be the difference between their cross product. A times D minus B, C. Let's see an example. Calculate the determinant of the following matrices. Okay, what matrices are we talking about? The first one, the matrix A, will be given by the numbers 5, -2, 3, and 1. Okay, this is the matrix A. Obviously, we want to take the reference, the position on the matrix, the number in the matrix, just like in the formula. Well, if you really want to calculate the determinant, it's simple. Determinant A will be equal to the difference of the cross product. I mean, we must multiply 5 times 1, subtracting, according from the formula, parentheses, -2 and +3. Okay, so basically at the moment going to apply the determinant, 5 times 1 will be 5, negative times negative will be positive, 2 times 3 will be 6, and 5 plus 6, the answer will be 11. And this is going to be the solution set for the first determinant, matrix A. Another example, if we have a matrix B, the values will be given, for example, 5/3, 2/5, 1/2, and 17. Oh, sorry. And 17. And we have to look for what will be the value from the determinant in that matrix. Well, simple, the determinant that matrix. The only thing that we have to do, it's use the formula once again. Remember, the determinant of the matrix will be provided by the difference of the cross multiplication. I mean, we must multiply 5/3 times 17, subtracting 2/5 times 1/2. Okay, this is going to be the formula for the matrix, at least the determinant of the matrix. Now, what we have to do? Well, the only thing that we must do right now is multiply the fraction 5/3 times 17. Let's see, 5/3 times 17, that will be equal to 85/3. We have 85/3. Okay, this 85/3 must be subtracted by -1/5, because 2/5 times 1/2 will be -1/5. For that reason, the determinant B will be equal to the difference between them, 85/3 minus 1/5. The answer will be 422 feet. 15, sorry, 15. And this is going to be the solution set, at least for the matrices 2 times 2. Please confirm, do you have doubts or questions at this part, or everything is clear?
Creo que todo claro, mister.
Todo claro, todo azul. ¿Y qué tal el sonido? ¿No hay eco ya?
Sí, se escucha bien.
Excelente, pues. Muy bien. Vamos a continuar entonces con the new example. Let me put this on this way. Okay. Now, we're going to explain what we have to do with the matrix, matrix C, but this time we're going to talking about what happened in that, just in case the matrix 3 times 3. Well, there's two ways we can solve the determinant for a matrix 3 times 3. The first method is what we call cofactors. Let me label this one. Look at the technique. Cofactors. This is the name of the method at the moment. I'm going to establish the determinant for any matrix 3 times 3. For example, given a matrix B, given B equals, okay, A, B, C, D, E, F, G, H, K. Okay, what we have to do in this cofactors methods, we want to take like a reference the first row, okay? And the first row, we want to have a set of signs assigned already. I mean, this is how to say that, this is for default settings in this formula for cofactors. Always before the first number will be located a positive sign, the middle one will be negative, and the third one, the default settings sign will be positive. Always, always, always. If you take the reference, the second row, the order will be the opposite. I mean, the first one will be negative, the middle one will be positive, and the last one will be negative. And if you take the reference, the third row, okay, the sign will be the same with the original one. But my advice, just for avoid any complications, take only the reference, the first row. How are we going to operate the determinant B from the matrix 3 times 3? Simple. Because we're going to take like a reference, take the reference, the first row of this matrix, just like this one. Okay, see what's going to happen. I'm going to write the letter A, obviously with the sign, or but if I leave only A, we are understandable. This is understandable. That will be a positive number. Okay, and we're going to create a matrix 2 times 2. How's that possible? Simple. Pay attention on this part. No big deal, not complicated, but you have to be focused in this moment what I want to say, because the process will be the same, okay? The row in the column will be located. The letter A will disappear. What numbers will be disappear? B, C, and D, G. What are the remaining variables in this case? E, F, H, K. Well, the remaining variables, this is what I'm going to write over here. E, F, H, K. Again, the row in the column where it's located the letter A will disappear, and I'm going to write the remaining variables, okay? Now, remember the second one, we have a negative sign, right? Well, I'm going to separate by negative B. And we're going to apply that logical sequence. When I'm talking about this case, the logical sequence means I'm going to erase imaginary. The row and the column will be located in the letter B. So in simple merely words, A and C will disappear. E and H will disappear. What will be the reminder variables? D, G, and F, K. D, G, F, K. Okay. And finally, the next symbol is positive C. And what would you think was going to happen over here? Anyone who wants to bring me that possible solution in that part C? What do you think going to happen? Anyone?
D.
Hola.
And there's gonna be DG, EH.
Excellent. DGEH. DGEH. Because the sequence established, okay, the row in the column where it's going to disappear, the letter C, where it's located, the letter C will disappear. That means will disappear AB and FK, okay? And we have at least the beginning of the sequences of the matrix for factors. I'll not continue developing this one because all of them, we have a matrix 2 times 2. We must apply the original formula. Now I'm going to solving this one like an example. If we have a letter C, okay, matrix C, we have -3, 2, 6, 0, 5, 7, 1/3, 1, and 0. Okay, we have this matrix C, right? And we're going to take the reference, obvious, and this compactor, you can take the reference, the first row, second row, or third row. But my advice, if you want to avoid some complications, take like a reference, the first row. And remember, the default setting of the sign, positive, negative, and positive, okay? What we're going to do, simple. We're going to start with -3, but before to write the number, must be multiplying the sign. Negative times positive, that will be what? Negative, okay? So then determinant C will be equal to -3, the matrix, obviously. Remember, the row in the column where it's located -3 will disappear. And we have the numbers 5, 7, 1, 0. 5, 7, 1, 0. Okay, and we had the first one. Now the second one will be the number 2. Positive times negative will be negative, right? Open the brackets. The row in the column where it's located, the number 2 will disappear. And the remaining numbers are 0, 7, 1/3, and 0. 0, 7, 1/3, and 0. Okay? And finally, the number 6, positive times positive will be positive 6. And what will be the remaining numbers? Remember, the row in the column where it's located the number 6 will disappear, and the results will be 0, 5, 1/3, and 1. Before to continue, understood under this form? Did you understand this part? Please confirm. Because I'm using full screen, I cannot see your faces. Please confirm yes or no.
Yes, Mr.
Okay, and as soon as I can see the screen and high quality imaging. Is that right? Can you see in the same way that I'm seeing in the mirror, in the screen mirror, please? ¿Están viendo la imagen de alta calidad no como un espejo?
Sí, Mr.
Ah, bueno, perfecto. Hasta grandecito lo miro yo, pero perfecto. Me alegra de eso. Okay, now let's continue because this is not the solution. This is the initial statement. Now let's going to calculate the determinant. Determinant C will be equal to, copy the -3, open parentheses or bracket as you wish. And because we have a matrix 2 times 2, let's going to apply the original formula. Remember the cross multiplication difference. I mean, 5 times 0 will be 0 minus y minus formula. 7 times 1 will be 7. And we have the first part. The second part, -2, open parenthesis again. Matrix 2 times 2 will be the cross multiplication difference. 0 times 0 will be 0. Minus, why minus? Once again, for the formula. Okay, 7 times 1/3 will be 7/3. And close parenthesis. And finally, I'm going to copy +6, and 0 times 1 will be 0. Minus 5 times 1/3 will be 5/3. Okay, and we are solving the determinant of matrix 2 times 2, but this is not the answer. Remember, always the answer that matrices 2 times 2 or 3 times 3, okay, always will be a number. Could be positive, could be negative, could be whole number, could be fraction, could be decimal, but there is no radical expressions. Don't worry, there is no square root or cubic roots if you think about it, because remember that numbers are irrational numbers, and that's not possible in matrices. Okay, let's calculate the determinant C. Well, you know, 0 minus 7 is -7 times -3 will be positive 21. The another one, 0 minus 7/3 will be -7/3 times -2 will be 14/3. And finally, 0 minus 5/3 will be -5/3 times 6, okay? 6 times 5 will be 30.
-10.
Yeah, well, -10. Yeah, you're right, -10. Okay, and let's finish this. Determinant C will be equal to 21 minus 10 plus 14/3. The solution will be 47/3. 47/3. And this is going to be the answer on the determinant C. For the first technique, cofactors. Okay. Do you have some doubts or questions on this far? Remember, if someone has doubts, please let me know, okay? Use your microphone because,
No podemos
Diga.
pasarlo de una a la calculadora.
Perdone.
Que si lo de arriba lo podemos pasar de una a la calculadora.
Lo de arriba específicamente en qué paso.
-3.
Esto.
Ajá.
Sí, lo pueden hacer directo en la calculadora, solo que yo lo hice paso por paso para detallar el proceso, pero sí, you can use your calculator at once. Siempre y cuando lo haga bien, no hay problema, ¿verdad? Pero si lo hacen mal, en este caso tendría que escribirlo exactamente como está aquí, -3, paréntesis 0, -7, -2, paréntesis y así sucesivamente. Y al hacer esto de aquí, se pasaría directamente a esto, ¿verdad? Solamente que lo quise hacer paso por paso para que fuese detallado lo que es el video. ¿Ok? There's another question. There is another question. No, there's no more questions. Okay. Did you copy the left side of this whiteboard already? Please confirm yes or no, because I cannot see your faces anymore. A ver, confirme.
Yes.
May I erase this part then?
Yes.
Okay. Well, now remember what did I explain you already. To calculate the determinant from the matrices, okay, we had 3 times 3. We had 2 ways. The first one is the cofactor method. And the second one, that will be the Sarrus law. Let me show you this one. You can use whatever you want. If you feel comfortable to use cofactors, you can do it. But if you want to use Sarrus Law. Actually, I don't remember if Sarrus is we going to write with S or Sept, but let me investigate that one later. Not pretty sure it's with S or C, but it doesn't matter. But that's matter is the name of the method, Sarrus law. I don't know if you rather to use the same matrix or if you wish we can use another combination. How do you like it? ¿Cómo les gustaría? Uso
La misma.
la misma. Okay, perfect. So in this method, the answer will be the same. It doesn't matter. Okay, we have this original matrix, right? Let me see, C equals, okay, the original matrix was -3, 2, 6, 0, 5, 7, 1/3, 1/3, 1, and 0. Okay, to calculate the determinant C, so by the way, can you read that numbers, right? ¿Pueden verlos? ¿Pueden verlo?
Sí.
Okay. Now, at the moment when to calculate the determinant C, what we have to do in this method, the main requirement in this situation is we must work in nilty, no chambon. Why? Take a look. I'm going to copy the numbers again, but with their separation, proper separation. And no -3, no. With a proper separation. 3, 2, 6, 0, 0, 0, 5, 7, 1/3, 1, 0. And I'm going to equal this matrix equal. Remember the dashed line in matrices, that means equal. Equal to what? The first two rows. The first two rows. Sorry, the first two columns. I mean, -3, 0, 1/3. This is the first one. And the second one will be 2, 5, and 1. And close parentheses. This is the first step. Now, the second step, I'm going to multiply the matrix by the diagonals, starting from to the left and the right side. I mean, I'm going to multiply -3 times 5 times 0. You know, that's why I'm saying you must to give them the proper space in this matrix. Just for remarkable, what will be the diagonals? Second one, 2 times 7 times 1/3. And finally, 6 times 0 times 1. At the beginning, I'm not saying that's it. No. We're going to apply determinant C. I'll do it step by step, but just for to summarize these arrows that indicate what numbers you're supposed to multiply. I can do it at once, but I do it step by step just for clearly understandable the process. We have -3 multiplied by 5 multiplied by 0. I'm going to add, always add the second sequence. I mean, 2 times 7 times 1/3. Adding the third sequence, 6, 0, and 1. I mean, 6 times 0 times 1. Okay? We are ending the first sequence. Now, because we have diagonals left to right, and as soon as you can see, there's diagonals to right and left. We have to go back. So the first diagonal to go back will be 0 times 2, 2 times 0 times 0. negative 3 times 7 times 1. And finally, 6 times 5 times 1/3. Okay, take a look, the orange arrow. But what's going to happen? Because we are going back, before to establish the process, I'm going to continue over here because I don't want to disturb the other side of the whiteboard. Because we're going to separate the first three elements by a negative sign, open a bracket. Remember, this is negative sign, open bracket, and just do it the same process. I mean, the first sequence, 2 times 0 times 0, 2 times 0 times 0, plus negative 3 times 7 times 1, negative 3 times 7 times 1, and plus 6 times 5, 6 times 5 times 1/3. And close the brackets. You can do it at once, okay? But I'm showing you this process step by step to the clearly understandable process, okay? So let's begin this. Determinant C will be equal to negative 3 times 5 times 0, you know, that will be 0. That over there, 6 times 0, 0 times 1, that will be 0. But 2 times 7 times 1/3, that will be 14/3. Okay? Subtracting, we can open a bracket or parenthesis as you wish. 2 times 0, 0, 0. Negative 3 times 7 times 1, that will be negative 21. Right? Plus 6 times 5 is 30. 30 times 1/3, that will be 10. Okay? And as soon as you can see, determinant C will be equal to 14/3, and you know, negative 21 plus 10 will be negative 11. And negative times negative will be positive 11. Okay? And if you add 14/3 plus 11, you know, 3 times 11 is 33. 33 plus 14, that will be 47/3. And this is going to be the determinant C by means of Sarrus method. Questions? Preguntas? Hola.
¿Será que puede repetir desde cómo sacó los números de los brackets?
Ok, perfecto. ¿Dónde dejé yo mi regla? Aquí está. ¿Qué pasó? ¿Me explico de las flechas o esto?
Eso de ahí, eso de ahí.
Bueno. Del bracket. ¿Se acuerda que aquí primero hicimos la multiplicación de los rojos, verdad? Que era la parte de arriba. Cuando voy a hacer la multiplicación de los anaranjados, como venimos de regreso, siempre lo va a separar por este signo negativo. Lo voy a remarcar un poquito aquí, solo que no le seguí la secuencia para no estorbar la parte que habíamos escrito. Ese menos y abrimos el corchete. ¿Y de dónde salieron esos números? ¿Ve usted todas las diagonales anaranjadas? No sé si la distingue. Confírmeme.
No, eso sí, sí.
Bueno, por eso le digo, 2 por 0, 0. Bueno, ahí está todo esto. Entonces, ¿qué hago? Para sacar estos números, voy a hacer las operaciones. Menos 3 por 5, 0, es 0. 2 por 7, 14 por 1/3, 14 tercios. Y este 6 por 0 por 1 es 0. Usted sabe, 0 más 0 más 14 tercios, 14 tercios. ¿Hasta ahí estamos bien?
Sí, sí.
Ajá. Luego, este signo menos, lo pongo acá. Hasta lo voy a colocar acá remarcadito otra vez. Abro el corchete y mire la operación que tengo dentro del corchete. 2 por 0, 0, eso es 0. Menos 3 por 7 por 1, eso es negativo 21. ¿Sí? Luego, 6 por 5, 30. 30 por 1/3, eso me da positivo 10. ¿Estamos hasta acá?
Entonces, en esos no se suma. Ah, no, se van sumando uno por uno.
Sí, se van sumando, pero tienen que tener cuidado con los signos, ¿verdad? Siempre hay que separar con un signo más, pero al final depende de qué signo tenga. Por ejemplo, aquí, a pesar que hay un más, recuerde que es negativo 21 más 10, entonces son signos diferentes, al final se resta. ¿Me explico? Marcela.
Sí, sí.
Bueno,
Sofía.
Sofía, ves, es que no le estoy viendo la cara por el coso este. Pero bueno, menos 21 más 10, ¿eso qué nos da? Negativo 11, ¿cierto? Pero como afuera está este signo negativo, menos por menos, ¿cuánto me da? Me da más. Entonces me queda 14 tercios más 11, resultado 47 tercios. ¿Me di a entender esta vez, Sofía?
Sí, mister, muchas gracias.
A la orden. Recuerden, muchachos, el requisito, si usted quiere usar la ley de Sarrus, es que al momento de dibujar la matriz, no vayan a hacer el método del chiquillazo, que normalmente ustedes hacen esto así. 2, 1, 3, 4, 5, 1, 0, 2, 1. Aquí a pegazón, porque si usted hace eso así, 0, 2, póngale 2, 4, 0, 1, 5 y el 3 así. Entonces, si usted hace un dibujito así, aparte que no se entiende nada, al momento de hacer la flecha, usted perfectamente puede llegarse a equivocar de diagonal por esa pegazón. Entonces, lo que sí es requisito grande para evitar una confusión es que trabaje como que le estuvieran pagando $100 para dibujar esta matriz bien dibujadita, bien alineaditos los espacios, para que así usted pueda ver con claridad cuál es la diagonal correcta para usar. De nuevo, determinantes de 2 por 2 es muy sencillo. Lo único que tiene que hacer al dar una matriz de 2 por 2 es la diferencia de la multiplicación cruzada. Siempre es así, diferencia de una multiplicación cruzada, comenzando de izquierda a derecha. Izquierda a derecha, menos derecha a izquierda. Punto. Eso es todo lo que es la matriz 2 por 2. Para calcular matrices, si usted me pregunta de 3 por 3, 4 por 4, 5 por 5 y así sucesivamente, pues el método es el mismo, puede hacerse por cofactores y por ley de Sarrus, solo que entre más grande es la matriz, más largo es el proceso, pero ahorita solo nos vamos a limitar a usar un máximo de 3 por 3. Recordemos en los cofactores, ¿qué es lo que hacemos? Podemos tomar como referencia la primera fila, segunda fila o tercera fila, cualquiera de las tres. Si toma como referencia la primera, la configuración por defecto de los signos sería positivo, negativo y positivo. Si quiere tomar como referencia la segunda, al revés, negativo, positivo, negativo. Y si quiere tomar como referencia la tercera fila, pues se vuelve al inicio, positivo, negativo, positivo. Cualquiera que usted tome va a dar el mismo resultado. Mi consejo para que no se complique la vida, tome como referencia la primera fila y punto. Y pues como les dije, si toma con la A, la fila donde está, es decir, B, C y D, G, se eliminan y se pone la matriz sobrante. Luego más por menos es menos B, A, C y E, H se eliminan y solo queda D, G, F, K. Perdón, déjeme ver, D, G, F, K, sí, perfecto. Y por último C, se eliminaría F, K, A, B y, perdón, y prácticamente pues solo colgamos el sobrante. Al tener una matriz de 2 por 2 como tenemos, aplicamos la formulita que está en color negro y punto. Problema resuelto. Y este, como les decía, nítido, hermosamente dibujado. Igualamos la matriz a sus primeras dos columnas y comenzamos a multiplicar los diagonales siempre separados con un signo más o de suma. La primera diagonal de izquierda a derecha, para allá. Tenemos el primer resultado. Y después tenemos que hacer el proceso opuesto. De derecha a izquierda, como que viene un regreso. Pero como usted viene de regreso, usted sabe que los regresos se consideran negativos. Ponemos un signo negativo y abrimos corchete porque al final ese signo negativo va a alterar todo el proceso. Y repetimos la avenida, las diagonales, Al final, hacemos estas dos operaciones y tenemos la respuesta. ¿Sí?
Puede cambiar los colores porque no puedo distinguir entre el anaranjado y el rojo.
Ok, vamos. Y el rojo sí. El rojo sí.
No, no los puedo distinguir, no, o sea, no importa cuál
Espérame,
cambie.
espérame, pues. Vamos a ver. Le vamos a poner ahí el negro y al negro azul no hay problema.
Ujú.
Ah, bueno. Vamos a empezar con el azulito, pues. De nuevo. Vaya,
O
jeez.
no puede ser como azul y rojo.
Vaya, pues. Pero con el azul, pa. Mire. Ahí está bien en el momento. Ahí está bien.
Sí, mister.
Ajá. Ahora me dijo rojo, ¿ah?
Ujú.
Ahí.
Simón.
Ah, bueno. Simón, hombre, órale, carnal. Ahí va. ¿Mejor?
Sí, mister.
Dale, pues. Ahí está. Y ese es el proceso. Ahora les pregunto, muchachos, ¿cuál de los dos métodos les pareció mejor a ustedes? ¿El de cofactores o el de Sarrus?
Cofactores.
Bueno, entonces, como les dije, les enseñé de las dos maneras. Si en el examen yo le pido, encuentre la determinante de la matriz, yo le voy a dar a usted la libertad. Solo le voy a decir, encuéntreme la determinante de esta matriz 3x3. Usted, si usted quiere usar con factores, pues dele con factores. Dele, quiere usar sarros, pues use sarros. Al final, si usted lo hace bien, el resultado será exactamente lo mismo. ¿Qué horas tienen? Me disculpan, por favor, mis estimados jovenazos. Yo tengo 9:15, ¿es correcto? Hola. Hello. Confirmen, 9:15 es correcto.
9:17, mister.
Ah, ¿y por qué no me dicen nada? Bueno, entonces eso es todo por hoy. Yo sé que van a recreo. Bueno, van a desayunar. Recreo no hay porque están en sus casas. Dios los bendiga, los guarde, los cuide. Los veo si Dios lo permite el lunes. Ojalá que no haya más estragos y que todo se normalice en la escuela. Este video, pues posteriormente, pues se va a subir. Ya saben ustedes en el canal. Si el video les es útil, denle like, suscríbanse y compartan. Recuerden, su compartir es mi sueldo. Cuídense mucho. Bendiciones, muchachos. Los veo en Physics.
Creo,
Cuídense.
mister.
Bye bye. Salam.
Bye,
Take
mister.
care of yourself. Cuídense.